Okay, awesome. Do we have a clicker or something, or no? Okay, that's fine. Hi everyone, this is Michael. I'm founder and CEO of Brevis. Today, on ZKTLS Day, I'm gonna basically go through a demo that we worked on to power the first Kaito, social leaderboard without kind of leaking your private information such as wallet addresses. So, but before I dive into, the demo itself, just want to kind of give you a quick introduction of what we do at Brevis, right? So, Brevis is trying to build what we call the infinite compute layer for Web3. It is a smart, verifiable computing platform powered by ZK. So, blockchains, as we know, are often advertised as water computers, but in reality, it cannot run faster than a single server, and it's also extremely expensive. Now, the fundamental reason for that is, you might think, okay, wait, that's not the case because we have done all this work in the last 10 years to actually improve the scalability of the layer 1 blockchain and layer 2 blockchains. We should be able to just run any kind of computation on them. Well, unfortunately, that is not the case. Something as simple as a trading fee kind of discount program based on the user's trading volume is not possible to be, kind of implemented in DEXs today until very recently. Now, the fundamental reason for that is that today's consensus is actually built on this paradigm of simple computing, where let's say you will have two nodes and want to convince each other the result of a certain computation. What you do here is that, let's say Alice here basically computes the result of the multiplication equation, and she's trying to convince Bob the result is actually correct. Now, how does Bob do this? Here is Bob is actually going to run the same kind of computation again. So, the entire kind of a blockchain consensus today is built on this paradigm of recomputation-based verification. What this means is that, let's say you have a swap transaction in your kind of a smart contract, which is very simple to compute if you're running a single node. But the problem here is that, now you're actually computing this on millions of nodes that is kind of running Ethereum consensus layer today. And this is fundamentally why the kind of a blockchain computation are still very expensive and cannot really kind of scale beyond a single server capability. So, the solution that we introduced here is something called verifiable computing. Verifiable computing is a different kind of a computing paradigm where you have different roles in the entire computing system. In this case, Alice, let's call her the prover. And, she is not only just computing the result of the equation, but also generating something called a ZK proof. And, she can just send a ZK proof, which is a magical piece of things. Since you guys are all here in ZKTLS today, I assume you know the kind of a background on this, that a verifier can spend a tiny amount of verification computation to actually kind of verify the result is done correctly. And with this kind of a new paradigm, we decouple the computation from the verification process. So ZK has been around for quite a long time. The reason it has been brought to the main stage recently is because of the gap between the orange bar and the blue bar here shrinked a lot. Before this, recent kind of a movement on ZK development, this kind of a gap between the original computation and the computation needed to compute the proof itself is like 1,000,000 times. But with the recent development of the kind of a ZK proving technology, we now shrink this kind of a gap between this and kind of the proof generation and the original computation to 2 to 3 orders of magnitude, which is very much kind of feasible as a scaling solution. So the nice thing, of course, about ZK is that no matter how complex your original computation is, once you generate the proof, the verification cost of this remains roughly the same. So, what we are building here is this kind of a verifiable computing platform where you can offload some very complex computation away from blockchain to the to kind of a Brevis, and inside of a Brevis, you can generate a ZK proof and submit the ZK proof back to the blockchain so the smart contracts or other validators in the blockchain can easily verify the proof and consume the result as if the entire complex computation happened on the blockchain directly. So, Brevis is not theoretical. We are powering numerous kind of top-tier projects and protocols such as MetaMask, PancakeSwap, Uniswap, Beefy, Euler, List.out, Open Eden, Euro, and all these. So these are not kind of vanity stuff. They are real in production use cases that are running live today. So today, in ZKTLS Day, I want to highlight a specific use case that we did with Kaito. So how many of you guys know what Kaito is? Do I need to kind of explain Kaito? Okay. Well, turns out that a lot of people actually don't know. So Kaito is this kind of a social, kind of what people call InfoFi platform that, tracks what is, the user's kind of influence level on Twitter. So it has different kind of leaderboard in different subcategory of the crypto space, like a ZK, different project and stuff like that. So, the idea here is that because we need to kind of help the project to raise awareness in the entire crypto community, so, the project can build their own leaderboard and monitor who are actually contributing the loudest social voice, and then, reward these kind of user properly when they actually launch the token, right? So, right now, however, before kind of we integrated with Kaito very recently, the only way to kind of track users' voices by analyzing their social account activity and nothing else. So this is a kind of a, as you can imagine, in the age of AI, you can have many kind of, garbage kind of a social content that is generated by AI and kind of essentially pollute the system, right? So, they want to basically have a way to essentially generate some level of attestation of like, okay, this user or this kind of a social profile is actually attached to some real user that are using on-chain applications and using kind of a meaningful, interactions with the protocol itself. However, they try to push this, but they've actually failed because, they start to realize that, first of all, people don't want to give them their Binance account API access. And second is even for on-chain data stuff, like people don't want to even kind of associate their main wallet with their social profile, right? So, so that's kind of like the challenge they face when they kind of first encounter this, and when they talk to us, and we say, okay, look, it seems that a ZKTLS is the right solution here. So, and also, of course, like for on-chain stuff, you don't really need ZKTLS, but for off-chain stuff, you actually need that. So we talked to them, and we start to kind of work together and build this new, user profile attestation system that allows user to attest to certain behavior these projects themselves are interested in kind of knowing, right? So let's say you're launching a DeFi project. Well, and you have a bunch of yappers that are yapping about this kind of a project, and you want to essentially give higher weight for some kind of a social, community who actually used a lot of DeFi protocols before, or who actually held a lot of DeFi tokens there in their centralized exchange account. So this is precisely what we built. On the purely on-chain side, we used our ZKVM to essentially build this kind of on-chain attestation platform that allows users to generate a privacy-preserving attestation about their on-chain behavior and on-chain user profile. Something like, okay, I have actually used Uniswap a lot in the past like 30 days, or I have held a certain token after airdrop without actually directly dumping it, right? So it becomes very useful for many projects. And, for the off-chain part, which is the part that you actually need to kind of connect with, your centralized exchange account, this is where the ZKTLS component comes in. We work with our partner Brevis to actually kind of implement this feature. But a challenge with like just ZKTLS protocol is that it is great tool to actually pull data. Raw data from like kind of let's say Binance.com. If you want to pull your trading history data, you can easily get that. But for many users, they don't want to even share their trading history directly with kind of the external party, right? They want to essentially generate a attestation showing that, okay, I'm a holder of the certain token, and my holding kind of amount time-weighted holding kind of amount is bigger than a certain current kind of threshold. They want to kind of generate this kind of attestation. Now, this is where the ZKVM component comes into play, where you can essentially use this kind of ZKTLS proof to actually recursively verify the proof firstly in a ZKVM, and then use ZKVM to write a very general and flexible program to process and compute on these data. And once you can compute on these data, you can essentially generate a proof showing the end-to-end result of your entire kind of a user profile. So I'm going to show you a demo here, which is a recorded demo, since I know the internet here is not so good. So the idea here is that once you kind of start to do the verification, there is a plugin that is installed on you. Oh, you really cannot see this, right? So, but yeah, so like there's a plugin that is installed on the user's browser, and this plugin is where the ZKTLS happens. And in this particular case, you got the user's kind of a trading history, right? So this is kind of a trading volume attestation. And then the next thing, what you do next is that you want to kind of have this data and send it to a ZKVM to do proving, right? So this is actually a tricky part because you don't want to kind of leak users' data to an external prover as well. So this is where we actually partner with some of the TEE providers to run the entire ZKVM computation process also in TEE. So, this way, what you can do is that you can basically now, generate an end-to-end privacy-preserving proof showing that, okay, for example, this time, this particular user didn't have enough trading volume, and therefore the end result is just like a true and false attestation. In this case, is false, but you don't actually need to leak your entire kind of a trading history and stuff. Now, after you made a bunch of trades in your Binance account, what you can now do is to do the verification, to do the attestation again, and after this step is a raw data, and this step is where you do the kind of a real you do the ZKVM based computation, and now the attestation result changes from false to true, right? So this is kind of a very, very simple example, and this data actually gets sent back to Kaito without actually revealing what is the user's UID or everything, but just to say, okay, this particular user with this social profile actually controls a Binance account with this and that kind of user profile. So for this particular demo, what I want to kind of show is really that ZKTLS protocols and ZKTLS solutions are most useful when combined with ZKVMs. And ZKVMs can essentially kind of run arbitrary computation on top of these data and generate useful insight that is kind of arbitrarily kind of testable to different applications need. So that's pretty much it. But just to kind of quickly go through this whole thing, that there are so many different use cases for Brevis as well. We power next generation decentralized exchange user experiences. We are building ZK-powered perpdexes with some of the leading perpetual swap exchanges. We're helping kind of a decentralized stable tokens to grow by building this kind of transparent, trust-free, and compliant reward distribution system, and so many more. So we believe that in 10 years, like 99% of the computation for blockchain application are gonna happen in the off-chain world and verified hopefully by ZK proof and hopefully by Brevis itself. So very quickly, just to kind of introduce what is actually inside this magic box. So we have this kind of a Pico ZKVM, which is right now the world fastest ZKVM available. And on top of that, we have a bunch of things called coprocessors to support specific kind of application need. As you can see, like when we work with ZKTLS solutions like Premise, we essentially use them as a coprocessor that can be recursively verified and plugged into the virtual machine system. And yeah, the rest of the stuff is not quite relevant to ZKTLS, but yeah, that's it. That's my talk. Thank you. Any questions? I think I have time for one question. All right, thank you guys again. Oh, sorry.
Hey, very interesting approach to using ZKTLS. A question regarding the Brevis ZKVM runtime. You mentioned it's programmable in Rust. Is it using a RISC-V based architecture, or is it WASM? What's the approach there?
Yeah, so like, Brevis Pico ZKVM is a RISC-V compatible ZKVM with a bunch of function level precompiles. So like, we basically accelerate certain kind of operations like catch hash and all these stuff. So yeah, so it's, in short, it's a RISC-V compatible one.
And 32 or 64-bit?
Sorry?
Is it like 32-bit or 64?
Right now it's 32 bits, and we're kind of extending this to 64 to support things like Go runtime and stuff. Yeah. Cool. All right. Thank you.